Hello everyone. So today we have 4 to the power of n plus 3 to the power of n equals to 91. The value of n must be positive integer. So we're going to solve together. Let's seek solution. So we can write 4 to the power of n and to the power of 1 plus 3 to the power of n to the power of 1 equals to 91. But 1 can be regarded as a over a is 1. And also 2 divided by 2 is also 1. But in this case, we will regard 1 as 3 over 3. 3 divided by 3 is 1. We want to represent 3 over 3 as 1 over 3 times 3. So in place of 1, we write 1 over 3 times 3. So the equation becomes 4 to the power of n to the power of 1 over 3 times 3, close the bracket, plus 3 to the power of n to the power of 3, 1 over 3 times 3, close this bracket, equals to 91. Again, we have a to the power of m to the power of n, which is equivalent to a to the power of m times n, also equals to a to the power of n to the power of m. So our equation becomes 4 to the power of n over 3 to the power of 3 plus 3 to the power of n over 3 to the power of 3 is equals to 91. So here we can say let 4 to the power of n over 3 be equals to a, and 3 to the power of n over 3 be equals to b. That means our equation becomes a to the power of 3 plus b to the power of 3 equals to 91. And we are fine. But from algebra, we have s to the power of 3 plus y to the power of 3, and is represented as x plus y times s to the power of 2 minus sy plus y to the power of 2. And a here is equals to x, while b is equals to y. And if we do this very well, our equation becomes a plus b from here times a to the power of 2 minus ab plus b to the power of 2 equals to 91. So since 91 is positive, it means that the value of a is greater than the value of b. And if that is true, that shows that a plus b is less than a squared minus ab plus b squared. But the factors of 91 can be represented as 1 times 91 and 91 times 1, 7 times 13, and 13 times 7. And if this is true, that means this and only this will be valid. So if we consider case 1, that is 1 times 91, our equation a plus b times a to the power of 2 minus ab plus b to the power of 2 will be equals to 1 times 91. So that a plus b will be equals to 1, and a to the power of 2 minus ab plus b squared will be equals to 91. We're going to call this equation 1. So if we simplify this further, we have a plus b to the power of 2 equals to 1 to the power of 2. And if we do this very well, it becomes a to the power of 2 plus 2ab plus b to the power of 2 will be equal to 1. And let's call this equation 2. And here, we're going to subtract equation 2 from equation 1. That is a to the power of 2 minus ab plus b to the power of 2 is equals to -1 for equation 1. And a to the power of 2 plus 2b plus b to the power of 2 is equals to 1. And if we solve this system of equation, we end up having minus 3ab, because a and b will be cancelled out, will be equals to 90. So that ab will be equals to minus 30. And this will be rejected because it's not a positive integer. For case 2, 7 times 13, a plus b times a squared minus ab plus b squared will be equal to 7 times 13. So that a plus b will be equal to 7, and a squared minus ab plus b squared will be equals to 13. We call this equation 3. And from here, we have a plus b to the power of 2. If we square both sides, and 7 to the power of 2 becomes a to the power of 2 plus 2ab plus b to the power of 2 equals to 49. 7 to the power of 2 is 49, and we are going to call this equation 4. So again, if we subtract equation 4 from equation 3, it becomes a to the power of 2 minus ab plus b squared equals to 13. This is equation 3. And equation 4, a to the power of 2 plus 2ab plus b squared equals to 49. And this is our equation 4. And if we solve this system of equation, therefore, this will cancel out. And here we have minus 3ab equals to minus 36. So that ab will be equals to 12. And this is accepted. It's a positive integer. But we're going to recall that a plus b is equals to 7. So if a plus b equals to 7, that means b is equal to 7 minus a. And if we compare this and this, we can therefore write that a into 7 minus a will be equals to 12. And this can be 7a minus a to the power of 2 minus 12 equals to 0. And if we multiply both sides by minus 1, it therefore will becomes a to the power of 2 minus 7a plus 12 equals to 0. And this is a typical quadratic equation. And if we want to factorize this, for the product is 12 and it's obtained by minus 3 times minus 4. Minus 3 times minus 4 is plus 12. And the sum is minus 7. And also obtained by minus 3 plus minus 4 as minus 7, and it's fine. So our equation therefore becomes a to the power of 2 minus 3a minus 4a plus 12 equals to 0. And if we factorize this very one, we have a into a minus 3 and minus 4 into a minus 3 equals to 0, and we are very fine. So the factors therefore are a minus 3 and a minus 4 equal to 0. So that the values of a will be equals to 3 and 4. And from here, we can have b to be 7 minus a And when A is equal to 3, B therefore will be equal to 7 minus 3, and this is equals to 4. And when A is equals to 4, B is equal to 7 minus 4, and this is equals to 3. So the values of A and B can be represented as 3 and 4, 4 and 3, respectively. But recall that 4 to the power of n over 3 was represented as A, and 3 to the power of n over 3 also was represented as B. And if we are going to do a simple analogy, so when A and B is equals to 3 and 4 respectively, 4 to the power of n over 3 will be equals to 3 to the power of 1, and 3 to the power of n over 3 will be equals to 4 to the power of 1. But from the laws of indices, a to the power of x equals to a to the power of 2, here we can derive x to be equals to 2, since the bases are equal. For this case, the bases are not the same, so this option is cancelled. But when A and B is equals to 4 and 3 respectively, 4 to the power of n over 3 therefore will be 4 to the power of 1, and 3 to the power of n over 3 also will be 3 to the power of 1. And again, since the bases are the same, the power therefore can be equated. And here the bases are the same, so we can write n over 3 equals to 1. And from here, n is equals to 3. Also here, n over 3 is equals to 1. Here, n also is equals to 3. So the two categories gave us n to be equals to 3. So to verify if this is true, we're going to bring back the original equation that says 4 to the power of n plus 3 to the power of n equals to 91. So that n would therefore be equals to 3 plus 3 to the power of n. Can this be equals to 91? But 4 to the power of 3, that is 64, plus 3 to the power of n, which is 3, is equals to 27. Can this be equals to 91? 7 plus 9, that is 11. Write down 1, carry 1. That 1 plus 2 is 3. 3 plus 6, that is 9. And definitely is equals to 91. That shows that the value of n as equals to 3 is true. Because it satisfies the equation, the right hand side is obviously equals to the left hand side. So look forward to see you in our next video. Bye bye.